What if a body could actually tell you its own story? Well, in the world of forensic pathology, it really can. Today, we're going to learn how to read that story by exploring how science interprets the final silent testimony of the human body. See, an injury isn't just a wound, it's a crucial piece of the puzzle. It's a clue that can unravel the entire sequence of events that led to a person's death. But here's the thing, the real secret is figuring out what came first.
So think of this as your first lesson in that language. We're going to dive into the evidence left behind by three major types of fatal injuries, and we're going to focus on the one thing that truly matters most, figuring out the primary cause of death in each case.
First up, let's explore those cases where the cause of death is, simply, a lack of oxygen. The scientific term for this is asphyxia, and for any investigator, understanding exactly how it works is absolutely critical. Now, the word that really jumps out on this slide is mechanical. This isn't about some disease or a chemical reaction happening inside the body. No, this means something physical, something external, is literally stopping a person from breathing. And drowning is a textbook example of this. It's not poison, it's just physics. The water physically takes up the space where air is supposed to be. It's a pure, simple, and tragic obstruction, which makes it a really clear-cut case of mechanical asphyxia. Okay, but that brings us to a much more complex and, frankly, often misunderstood scenario: hanging. What is the precise biological event that actually proves fatal? Is it a broken neck? Or is there something else going on? So the crucial point here is this. Just like with drowning, the primary cause is a physical blockage. The pressure on the neck obstructs the airway, and that cuts off oxygen to the brain. This leads to a state called hypoxia, which is just a way of saying not enough oxygen in the blood, and that is the very first and most critical link in this deadly chain of events. And this is a perfect example of what a forensic pathologist does all day. They separate cause from effect. A cardiac arrhythmia might happen, for sure, but it happens because the brain is being starved of oxygen. It's a result, not the initial cause. And the same thing goes for these other theories. They're all consequences, not that all-important first link in the chain. All right, so now that we've got a handle on how an internal obstruction can be fatal, let's switch gears and see what happens when the force comes from the outside. We're moving from asphyxia to the devastating effects of blunt force trauma. The key word here is blunt. We're not talking about something sharp, like a knife. We are talking about impact, pressure, a crushing force that causes tissue to tear. And that leads to a really important distinction that forensic experts have to make. In everyday language, we might call both of these a cut, but in forensics, precision is everything. An incised wound, that's a clean slice from a sharp object. But a laceration, which is what we see with blunt force, is actually a tear. And that one small distinction can tell an investigator exactly what kind of object was involved. Okay, so let's focus on the most critical area of the body, the head. When a person suffers a really severe blow to the head, what's the specific event that most often leads to death? And here it is. It's not usually the skull fracture itself or even that initial impact. The most common cause of death is intracranial hemorrhage, which is really just a technical way of saying bleeding inside the skull. And once again, we see it's a chain reaction. The impact causes the bleeding, but the skull is like a fixed box. It can't expand. So as blood starts to fill that space, the pressure just skyrockets, crushing the delicate brain tissue. That final fatal step is called brain herniation. The key takeaway here is that it's the bleeding that kicks off this whole deadly cascade. All right, for our final section, we're looking at one of the most destructive forces out there, a gunshot wound. Now, the mechanism here is pretty unique, but as we're about to see, that underlying principle of a chain reaction, it still applies. So what is it about a bullet that causes such catastrophic damage? Is it the metal it's made of? Is it just the fact that it punctures the body? Well, the core scientific reason is actually all about energy. Believe it or not, a gunshot wound is, fundamentally, a highly concentrated and extreme form of blunt trauma. A bullet's incredible speed gives it a massive amount of kinetic energy. When it hits the body, all that energy is transferred in a split second, creating this devastating shockwave that tears, crushes, and pretty much obliterates tissue far beyond the bullet's actual path. And just like before, it's so important to distinguish the primary cause from all the effects. I mean, yeah, the skull might be penetrated, and of course blood vessels are going to rupture. But those are results of the blunt trauma that the bullet delivers. The lead in the bullet? Totally irrelevant to the immediate cause of death. It's the kinetic energy. That is the true mechanism of injury. So, after looking at asphyxia, blunt force, and firearms, what's the common thread here? What's the fundamental lesson that forensic pathology really teaches us? And this is really what it all boils down to. In every single case we looked at, death was the end of a sequence. A cardiac arrest happened because of a lack of oxygen. Brain herniation happened because of internal bleeding. The job of the forensic pathologist is to trace that chain of events all the way back to find that very first link, the primary, initiating event. Ultimately, that's what this is all about. The body holds the facts of its own story. But without the precise language and the rigorous method of science, that story just remains unreadable. Science is the translator that gives a voice to the evidence. And that leaves us with one final and I think crucial thought. By meticulously understanding the mechanisms of injury, the exact reasons why a life ends, we gather this incredible amount of data. So the question becomes, how can we use that knowledge not just to solve crimes, but to build safer cars, to design better safety equipment, and ultimately to prevent these kinds of tragedies from happening in the first place? Thanks for joining me.